Over the past 4 decades, operating systems have quietly shaped the modern world. They began as invisible layers of code that translated human intent into machine action. But in 2026, they are something far more strategic. They define ecosystems, regulate hardware capabilities, manage identity, enforce security boundaries, and increasingly determine how software itself is distributed and monetized. What we are witnessing today is not just a technical shift, but a philosophical one. Windows is evolving from a traditional product into a continuously delivered service, while Linux is transforming from a niche alternative into a foundational global platform. Together, these shifts revealed the future of operating systems, a future where the OS is less about installation media and more about influence, integration, and infrastructure. For most of its history, Windows was a boxed product. You bought a license, installed it on a machine, and that was your computing environment for years. Updates were periodic, sometimes disruptive, often optional. Enterprises locked versions in place for stability. Consumers upgraded when they bought new hardware. The relationship between user and operating system was transactional and static. That model began to crack as the internet matured. Continuous connectivity made it possible to patch systems remotely, deliver features incrementally, and collect telemetry at scale. Security threats accelerated the need for rapid updates. Cloud services blurred the boundary between local and remote computing. Gradually, Windows stopped being a finished product and became an evolving environment. By 2026, the transformation is unmistakable. Windows is no longer defined by major version numbers as much as by update channels, subscription tiers, and cloud integration layers. The operating system is deeply entangled with online identity systems, enterprise management tools, and cloud-based services. Licensing increasingly revolves around subscriptions and bundled service offerings rather than one-time purchases. Even for consumers, the OS experience is shaped by persistent connectivity, integrated AI features delivered from the cloud, and features that can be activated or deactivated dynamically. The line between local operating system and remote service has thinned almost to invisibility. This service-oriented approach fundamentally changes the incentives behind development. Instead of delivering a complete package and moving on, Windows now operates under continuous improvement logic. Telemetry informs design decisions in near real time. Features can be A/B tested at scale. Security patches are deployed with urgency and frequency. The operating system becomes a living environment shaped by data feedback loops. For enterprises, this means more predictable update cadences and centralized management. For consumers, it means fewer dramatic upgrades, but more subtle, ongoing changes. For developers, it means targeting a moving platform that evolves under their feet. Security is perhaps the strongest driver behind Windows becoming a service. Modern cyber threats move at machine speed. Traditional patch cycles are too slow. By treating the operating system as a continuously maintained service, vulnerabilities can be mitigated more rapidly. Endpoint protection integrates with cloud-based threat intelligence networks. Identity management is centralized. Hardware-based security features are enforced through policy frameworks that are themselves updated remotely. The operating system becomes part of a broader security ecosystem rather than a standalone defensive layer. Artificial intelligence also accelerates this service model. Many advanced AI capabilities rely on cloud infrastructure, massive models, and constant refinement. Integrating AI deeply into the OS requires ongoing updates, feature toggles, and adaptive interfaces. As AI assistants become embedded in file explorers, search functions, and productivity tools, the operating system must continuously evolve to incorporate new models and capabilities. Delivering AI as a static feature would be impractical. Instead, AI becomes a service layer woven through the OS fabric. At the same time, Windows is increasingly decoupled from specific hardware configurations. Virtualization, cloud desktops, and remote work environments allow users to access their Windows session from multiple devices. In some cases, the operating system runs partly in the cloud and partly on the endpoint device. The identity layer synchronizes settings, files, and preferences across contexts. This shift reduces the importance of the physical machine and elevates the importance of the account and service layer. Windows becomes less about what is installed and more about what is provisioned. While Windows moves toward a service identity, Linux is traveling in a different but equally transformative direction. Historically, Linux was perceived as an alternative operating system for enthusiasts, servers, and developers. It was modular, open, and community-driven. Unlike proprietary systems, It was not tied to a single vendor. Its flexibility allowed it to run on everything from supercomputers to embedded devices, yet for many years, Linux remained fragmented on the desktop and invisible to mainstream users. That invisibility turned out to be deceptive. Linux quietly became the backbone of the internet. The majority of web servers run on Linux. Cloud infrastructure is overwhelmingly powered by Linux distributions. Containers, microservices, and orchestration systems are deeply rooted in Linux kernel capabilities. Smartphones rely on Linux-based systems. Even many consumer devices, from routers to smart appliances, operate on customized Linux builds. In effect, Linux became a platform long before most people noticed. By 2026, Linux is not merely an operating system, but a universal substrate for computing. Its kernel is a shared foundation upon which countless specialized environments are built. Containerization technologies leverage Linux namespace and control groups to isolate workloads. Cloud providers optimize Linux kernels for massive data centers. Hardware manufacturers ensure compatibility with Linux drivers to reach enterprise and developer markets. The platform's openness encourages experimentation and customization at a scale unmatched by closed systems. The concept of Linux as a platform extends beyond servers. Developer ecosystems are increasingly Linux. Programming languages, toolchains, and DevOps workflows are designed with Linux environments in mind. Continuous integration pipelines assume Linux containers. Infrastructure as code scripts target Linux-based virtual machines. Even on non-Linux desktops, developers frequently rely on Linux subsystems or virtual machines. Linux becomes the default runtime assumption for modern software architecture. One of the most significant enablers of Linux's platform status is containerization. Containers abstract applications from the underlying system, but they depend heavily on Linux kernel features. This creates a virtuous cycle. As more applications are packaged into containers, more infrastructure must support Linux semantics. Cloud-native design patterns reinforce Linux dominance. Kubernetes clusters orchestrate Linux-based workloads across distributed environments. Enterprises standardize on Linux images to maintain consistency across development, testing, and production. Open source governance plays a central role in Linux's platform evolution. Unlike a single vendor operating system, Linux evolves through collaboration among corporations, independent developers, and nonprofit foundations. This distributed governance model allows rapid adaptation to new hardware architectures and emerging use cases. When new processor designs appear, Linux support often arrives quickly. When new security mechanisms are proposed, they are debated openly and integrated through community consensus. This flexibility enhances Linux's appeal as a neutral platform. The rise of alternative hardware architectures also strengthens Linux's position. As energy efficiency becomes critical for data centers and edge computing, new chip designs challenge traditional dominance. Linux's portability enables rapid support for diverse architectures. This reduces vendor lock-in and encourages hardware experimentation. Cloud providers can deploy custom silicon while maintaining compatibility with mainstream Linux distributions. The operating system becomes a unifying layer across heterogeneous hardware landscapes. Interestingly, Windows and Linux are no longer strictly opposed. Interoperability has increased dramatically. Windows supports Linux subsystems that allow developers to run Linux environments natively. Cloud platforms offer Linux and Windows instances side by side. Containers can encapsulate applications regardless of the host OS. This convergence reflects a pragmatic reality. Modern computing is hybrid. Enterprises choose tools based on workload requirements rather than the ideological allegiance. The service transformation of Windows and the platform consolidation of Linux intersect in the cloud. Cloud computing abstracts physical infrastructure and emphasizes service delivery models. In this environment, operating systems function as orchestration layers rather than standalone entities. Windows integrates deeply with enterprise cloud ecosystems, offering identity policy enforcement and productivity services. Linux underpins the scalable infrastructure that powers these services. Together, they form complementary layers of a global computing stack. From a business perspective, Windows becoming a service aligns revenue with ongoing engagement. Subscription models provide predictable income streams. Bundled services increase customer retention. Continuous updates reduce fragmentation and support costs. This model mirrors broader trends in software distribution, where streaming services replace physical media and software subscriptions replace perpetual licenses. The operating system joins this shift toward recurring value delivery. Linux's platform status, on the other hand, generates economic value indirectly. Companies monetize support enterprise distributions, managed services, and specialized tooling. Cloud providers build profitable businesses on top of Linux infrastructure. Hardware vendors expand markets by ensuring Linux compatibility. Open source contributors gain reputational capital and career opportunities. The platform thrives because it enables a diverse ecosystem of commercial activity without central ownership. For developers, these shifts redefine strategic considerations. Targeting Windows increasingly involves integrating with service APIs, cloud identities, and subscription-based features. Applications may depend on OS-provided AI capabilities or security frameworks that evolve over time. Developers must anticipate continuous change rather than fixed environments. For Linux-focused development, the emphasis lies in portability, container compatibility, and orchestration readiness. Writing software that runs reliably in Linux containers across multiple clouds becomes a baseline expectation. End users experience these transformations in subtle ways. The traditional ritual of installing a new operating system fades. Instead, devices update quietly in the background. Features appear gradually. Interfaces adapt based on usage patterns and AI-driven insights. On the Linux side, users may not even realize they are interacting with Linux-based systems, whether through web services, smartphones, or embedded devices. The operating system becomes less visible but more pervasive. Education and workforce development reflect this new reality. Learning Linux is increasingly synonymous with learning modern computing infrastructure. Students who understand shell environments, containerization, and open source collaboration gain advantages in cloud-oriented careers. At the same time, familiarity with service-oriented Windows environments prepares professionals for enterprise IT roles where identity management and endpoint security are paramount. The future workforce navigates both ecosystems fluidly. Regulation and digital sovereignty introduce additional complexity. Governments seek greater control over digital infrastructure. Linux's open source nature appeals to initiatives aiming for transparency and independence from foreign vendors. Custom national distributions and localized security audits become feasible. Meanwhile, service-based Windows environments must comply with regional data protection laws, influencing how cloud integration and telemetry are managed. The geopolitical dimension of operating systems becomes increasingly significant. Edge computing further blurs boundaries. Devices at the network edge require lightweight, secure operating environments capable of remote management. Linux's modularity makes it well-suited for embedded and edge scenarios. At the same time, Windows adapts to running constrained environments with centralized oversight. Both ecosystems extend beyond traditional desktops and servers into industrial systems, autonomous devices, and smart infrastructure. The philosophical contrast between service and platform is profound. A service implies centralized control, continuous delivery, and subscription-based relationships. A platform implies shared foundations, extensibility, and decentralized innovation. Windows leans toward the former, Linux toward the latter, yet neither is purely one or the other. Windows still supports extensive third-party ecosystems. Linux distributions sometimes bundle commercial services. The boundaries are porous, reflecting hybrid realities. Artificial intelligence may ultimately redefine what an operating system means. As the AI agents become capable of orchestrating tasks across applications and services, the OS may serve as a coordination layer for intelligent workflows. In a service-oriented Windows model, AI features can be updated centrally and improved globally. In a Linux platform model, AI frameworks can be integrated at the infrastructure level, optimized for diverse hardware, and deployed in containers. Both paths converge on a future where the OS mediates between human intent and machine intelligence more actively than ever before. Sustainability considerations also influence operating system evolution. Data centers consume vast amounts of energy. Linux's efficiency and adaptability support optimization efforts at scale. Custom kernels can reduce overhead for specialized workloads. On the client side, service-based Windows updates can extend device lifespans by improving performance and security without requiring complete replacements. Extending hardware longevity aligns with environmental goals and economic efficiency. The developer experience continues to unify around cross-platform tools, webby technologies, container runtimes, and language ecosystems abstract away many OS-specific details. This abstraction reduces friction between Windows and Linux environments. Developers can build once and deploy anywhere, provided the runtime environment is compatible. The operating system becomes less of a barrier and more of a foundation. Looking forward, the most striking aspect of this transformation is invisibility. The future of operating systems is not about flashy interfaces or dramatic version launches. It is about seamless integration, background intelligence, and reliable infrastructure. Windows becoming a service means it will continuously adapt without demanding constant user intervention. Linux becoming a platform means it will underpin systems without always announcing its presence. The OS fades into the background even as its strategic importance grows. In 2026 and beyond, success for an operating system will depend on adaptability. Threat landscapes evolve, hardware architectures diversify, user expectations shift toward instant access and intelligent assistance. Regulatory pressures reshape data flows. In this fluid environment, static software models struggle. Service models thrive on iteration. Platform models thrive on extensibility. Windows and Linux embody these complementary survival strategies. Ultimately, the future of operating systems is not a zero-sum contest. It is a layered ecosystem. Windows excels at delivering integrated managed experiences tied to identity and productivity services. Linux excels at providing a flexible, open foundation for global infrastructure and innovation. Together, they form the dual pillars of contemporary computing. One emphasizes continuous service delivery. The other emphasizes universal platform capability. As viewers consider where technology is heading, it becomes clear that operating systems are no longer mere tools. They are strategic environments that shape economic models, security architectures, and innovation pathways. Windows becoming a service reflects the logic of a connected, subscription-driven world. Linux becoming a platform reflects the logic of distributed, open collaboration at planetary scale. The future of operating systems lies in this dynamic interplay, where service and platform converge to power a digital civilization that is always evolving, and increasingly intelligent.